Now we're going to talk about something called closest point of approach, or CPA. Your CPA, as the name implies, is how close will this contact get? Will any given contact get to us? What is the closest it will get to us? In other words, if it's going to get dangerously close to us, how close is that going to be? And the way you determine it is the CPA of a contact is when the contact is the point at which the contact's direction of relative motion, you could draw a perpendicular line off of it, and the perpendicular line would head straight to your position, to your point in the scope. Described otherwise, it would be the point that is the radius of a circle that their direction of relative motion would be tangent to. You don't need to know, or you should understand what both of those mean. However, it's not really important. How to plot it is, like I said, with the first definition, if you were to draw a perpendicular line from your direction of relative motion and it intersected your position in the center of the scope, that would show you your CPA. So, remember, if you want a perpendicular line off of a triangle, you can take this line here, which is 90 degrees offset from the hypotenuse of the triangle, and line it up with whatever line you want to make perpendicular. You could do the same thing with a Weems plotter, but their line is not as precise, which is why I don't like it as much. I think the triangles do a better job of this. So you line up the triangle with the 90-degree line, in line with the DRM of contact A, and you slide the triangle up ever so slowly, keeping it perfectly in line with itself until you reach the center of the scope. And then once you get there, you clean it up and you make a little line. You can take it out nice and far. And that point right there is the CPA of contact A. It's the closest point of approach. And what I meant by the second definition about having it tangent is if we, using this distance right here, were to create a circle around our position, the CPA is the only point where that circle contacts the direction of relative motion. You can see here. Again, I wish I had a compass. You can see that the tangent point from the circle to the DRM is the CPA right here. CPA of contact A. So for the whole time that contact A is approaching us, it'll get closer and closer and closer and closer. And then this is the closest point it will ever get to us. And then it will slowly start to come away from us after it's past CPA. Let's do the same with contact B. So we make our line perpendicular by lining up the 90 with the DRM of contact B. We slide it up, make sure it's nice and clean. And once it's in position, we take our pencil and we draw out. And there we go. That is the CPA of contact B. Normally we don't label it or circle it. I'm just doing that for the purposes of you seeing it more clearly. But that is our closest point of approach for contact B. And you can see it's a lot closer than contact A right there.